Let's take a look at project schedule management. The purpose of schedule management is to complete a project within the timeline agreed with customers. To this end, a project team should efficiently allocate resources according to the project schedule and identify the project activities and dependencies between each activity to develop the final schedule. These processes are what we call schedule management. The first phase of schedule management is planning. Project schedule planning is a process for policy making, procedure formulation, and documentation on project schedule, from initiation, planning, execution, monitoring, and control through closure. A project schedule management plan is developed based on shared documents, such as project management plans, a project approval, and project schedule monitoring criteria. The following screenshot shows an example of documents for reporting and sharing a project schedule plan. Such a document also needs to specify the frequency of meetings. The second phase of schedule management is activities defining. This is a process of defining project activities based on project scope and requirement statement. At the beginning of a project, it's very difficult to identify all activities. The presence of a similar project or experts in the relevant field would make it relatively easy to define the activities. On the other hand, the lack of experiences or a new emerging field would make it very difficult to even define the activities. Hence, the WBS decomposition and the rolling wave planning can come into play in order to refine the activities with an iterative and progressive elaboration. Once defined, the activities can be organized in a sequential or parallel order. We call this sequencing activities. Sequencing project activities refers to the process of identifying the dependency between the activities and organizing the activities in logical order. For example, when you construct a building, you cannot raise a second floor without a first. Then there exists the dependency between the two floors. Sequencing the activities represents this phase. There are 4 types of dependencies that describe the logical relationships between activities: FS, FF, SS, and SF. The FS relationship is the most widely used one among the 4 types. It refers to finish to start, which means that the completion of a predecessor activity leads to the initiation of a successor activity. For example, the completion of the writing phase is followed by the initiation of the deletion phase. The next is the FF relationship. In this relationship, all related activities are completed when two related activities are completed. In the example, the analysis phase is complete only after the writing and deleting phases are completed. The next is the SS relationship. It refers to start, which means that the initiation of a successor activity depends upon the initiation of a predecessor activity. That is, the initiation of development depends upon the initiation of planning. Lastly, the SF relationship. It refers to start to finish, which means that a linked activity cannot be completed until a predecessor is initiated. For example, in a 3-shift workplace, B can leave the office only after A arrives at the office. The activities categorized by each relationship can be sequenced using the project schedule network diagram. Next, activity resources estimation. Estimating activity resources is the process of estimating the quantities of resources required to perform the activities in the WBS. During this process, the activity lists and resource calendar serve as reference. Consequently, the resources required for the activities are estimated based on the availability and competency of human resources. Let's take an example. In the bulletin board project, the development of a file upload component requires an upload component developer, having at least medium-level skill. Such a requirement is deemed necessary in this process of estimating activity resources. Now we should estimate how much time it would take to complete each activity with the estimated resources. To that end, we can use the following 3 techniques: expert judgment, analogous estimating, which refers to the previous similar projects, and 3-point estimating. 3-point estimating technique is used where there is not much experience in the field and when the duration needs to be estimated based on the risks associated with the project. The term 3-point has the following meaning. Optimistic refers to an estimate of the shortest activity duration. Most likely refers to an estimate of the most probable activity duration. And pessimistic refers to an estimate of the longest activity duration under the worst-case scenario. This technique estimates the duration with the weighted average of 3 values. The average can be calculated from the following formula. Next, schedule development. Schedule development is the process of creating the project schedule model by estimating the activity duration. Starting from the left column, the table consists of a list of activities, estimated durations, start dates, finish dates, progress rates, and names of resources. The chart at the right is graphical representation of the project schedule. This is called a Gantt chart, and it represents milestones of activities in each project. This is what we call a project schedule. There are 2 most widely used techniques for creating a project schedule. First, critical path method. Every project has different activities between its start and closure. CPM is the most preferred technique for project schedule management. It is the critical path connecting activities with 0 total float. As you can see in the table, critical path method is the schedule management technique that takes into account activity sequences, durations, and dependencies. Second, critical chain method. This schedule management technique takes into account the limited human resources available for a project. For example, let's assume that 2 activities in a project are in a parallel relationship. If only one person can perform an activity, the parallel relationship is not maintained. Because if only one person can undertake an activity, it involves dependencies, not a parallel relationship. Given that a person cannot perform two activities at the same time, the critical chain method takes into account the limited availability of resources with regard to project scheduling. Next, I would like to introduce a technique for resource optimization. The resource leveling technique is a case in point. This technique requires less resources during earlier phases of a project compared to the middle phases. So, assigning too many resources would be inefficient. During the middle phases of a project, however, there would be much more activities assigned to resources. In other words, it is a resource leveling technique, adjusting resource usage during specific periods of the project in order to prevent uneven resource utilization. As you can see in the following chart, resources are assigned to week 1, 2, 3, and 4. Week 1 has more resources allocated, and week 2 and 3 have less. Part of the tasks in week 1 can be moved to week 2, part of the tasks in week 2 to week 3, and part of the tasks in week 3 to week 4. By doing so, you can minimize the resource usage fluctuation and balance the resources within the project schedule. This is what we call resource leveling. Let's take a look at schedule compression techniques, which help make up for the delayed schedule or complete the project earlier than planned. Crashing and fast tracking are the two most widely used techniques for schedule compression. Crashing is a schedule compression technique in which more resources are assigned. Human resources are assigned to each activity on the critical path. If one more person is added in order to facilitate a specific activity, the schedule is more likely to be shortened. We call such a technique of adding more resources to a specific activity crashing. Fast tracking is a schedule compression technique used to shorten the project duration by changing the dependencies among sequential activities and undertaking them in parallel. It is effective only for the activities that can be undertaken in parallel, and undertaking the activities in parallel may increase the risk of rework. The following is the final phase of schedule management: schedule control. Schedule control manages changes to the schedule baseline. It also monitors and controls the status of project activities. Let's take a look at the following example. The analysis phase has an activity named Write. This activity was supposed to be completed on July 31st. The entire analysis phase would be completed on August 20th, only when each of such activities is completed as scheduled. In this way, the phase of controlling schedule monitors the status of delayed schedule and manages changes to the schedule baseline. Now, let's take a look at project cost management. Project cost management is a set of processes involved in planning, estimating, budgeting, and controlling the costs so that the project can be completed within the approved budget. The following table is an excerpt from the Guideline for Estimation of Software Development Costs in Korea. In particular, software cost estimation involves the function points model and the software effort model. Therefore, a cost management plan must include which model will be applied to the project. Next, costs estimation. Costs estimation is the process of developing estimates of costs needed to complete the activities of the project. The following is cost estimating techniques. Previously mentioned analogous estimating, bottom-up estimating, in which the costs of each single activity are estimated with the work package level details at the bottom and then roll up to calculate the total project cost. expert judgment, and previously mentioned 3-point estimating. Estimating costs is followed by budget determination. Budget determination is a process of summing up activity cost estimates in order to obtain an approval of the baseline for project costs. In general, the project budget of a company begins with development costs. The profit takes up less than 25% of development costs, and the direct costs include development equipment fees, utility costs, printing cost. The sum of those three costs represents the project budget. In addition, such project budget must be included in the project agreement later on. Lastly, the process of cost control. Controlling costs is the process of monitoring the status of the cost management and managing changes to the cost baseline. The following contents that I am going to explain are challenging to ordinary students or even project managers, so I hope you will pay close attention. Let's take a look at the following table, particularly the progress of the right activity scheduled to be completed on August 1st. Currently, the activity shows about 90% of progress rate as of July 31st. The right activity has a duration of 5 days, and it is scheduled to be completed on July 31st. Assuming that today is August 1st, the writing activity has not been completed yet. Let's calculate the work completed in terms of cost so that we can monitor the control of overall cost management. Assuming that the daily cost is $300 US per one developer, the cost of the work completed becomes $300 US per day. The right activity was assigned a duration of 5 days, and its progress rate is 0.9%. The resulting cost of the work completed becomes $1,350 US, but the cost of the work based on the schedule initially planned is $1,500 US. In other words, the work worth $150 US is not completed. Therefore, this project is $150 US over the budget. The cost control management technique explained above is called the earned value method. The earned value management covers both schedule and cost of a project. This technique allows us to analyze a project's performance and forecast the final cost and schedule of the project at the present time. The following diagram is the earned value management graph using project schedule and accrued cost. In order to understand this graph, you need to know the following 3 terms. The 3 key terms of the earned value management are PV, EV, and AC. First, planned value, or PV, refers to the budget approved to be allocated for the work to complete activities or any works defined in the work breakdown structure. The right activity has a duration of 5 days, and the cost of the work completed is $300 US per day. Therefore, the budget of $1,500 US becomes PV. Second, earned value, or EV. EV refers to the budget assigned for the work actually completed as of the present time. Assuming that a 5-day work is 80% complete, a 4-day work has actually been completed, which becomes EV. Third, actual cost, or AC. AC refers to the cost actually incurred for the work undertaken. For example, a 5-day activity is behind the schedule, and 1 person is added for 1 day. Therefore, we can say that the duration of 6 days is allocated for the right activity. Let's take a look at the diagram once again. The y-axis and the x-axis represent the accrued project cost and the project schedule, respectively. The blue line represents the scheduled amount of work. The green line represents the amount of work actually completed. In the previously studied example, EV becomes 4 days, PV becomes 5 days, and the actual cost, or AC, becomes 6 days. Here, the cost variance is EV minus AC. If CV is positive, the task is under the budget. If CV is negative, the task is over the budget. The calculated cost variance is -2, which means that the cost of the project is over the budget. This can be converted to the cost of $600 US. Therefore, a project manager must be capable of project cost management through earned value management.